This is day 19 of Unit 5. So we didn't have a warm-up today, but we started right away with the problem from yesterday that we were working on at the end of class, which was problem number 4 on worksheet 5. So that's what we started with. So we're going to start there now. So I think right at the end of class, we had already done Descartes to know that there were 2 or 0 positive real roots and 2 or 0 negative real roots. And we had done rational root theorem to get our list of possible rational zeros. We had done an XY table, and it was that. And we knew the end behavior was up, up. The y-intercept was 0, 36, and we were working on finding the zeros. So our table didn't give us any zeros, but we saw a sign change here between these two numbers. It went from negative to positive, which means there has to be a 0 between -1 and 0. So using our list from rational root theorem of the possible rational zeros, and realizing that some of those on the list are between 0 and -1, we went through and we tried all of the numbers that were between 0 and -1 until we found a 0 remainder when we used synthetic division. And I think -1/3 is the one that we found to work. So I'm just going to quickly go through that. Remember, when you're looking at your coefficients, remember to fill in zeros if there's any missing terms. So I don't think we're missing any terms here. We have 6, we have -13, we have -68, +87, and +36. So 6 comes down times -1/3, which is 6 divided by -3, which is -2, plus -13 is -15. -15 divided by -3 is +5. -68 plus 5 is -63. -63 divided by -3 or times -1/3 is what? 21. Plus 87 is 108. 108 divided by -3 is -36. And indeed, we have our x equals -1/3 is a root. So from here, we know that there are 2 or 0 negative real roots, and we just found 1 negative real root, which means 0 is out. It has to be 2. So also from Descartes, I know that there's 2 or 0 positive real roots, but I don't know whether there are 2 or there's none. So when I'm here trying to decide what the roots are and which ones to try using my list from rational root theorem, I'm not going to try positives because it's a possibility that there's no positives. So I could go through this entire list of positive numbers and none of them work. None of them turn out giving me a 0 remainder. So I'm not going to try any of the positives. I know for certain that there is a negative real root. So there's more certainty that I'm going to find a negative real root than a possibility of me finding any positive real roots. Now, again, there might be 2, but there might be none. So I'm going to use the negative roots from my list from rational root theorem. Now, keep in mind, though, before I do that, I am going to check this equation that I'm left with, which is cubic, 1 degree less than the original, and set it equal to 0 and see if I can factor it. Because if I can factor it, then I don't even have to go through synthetic division a second time. However, unfortunately, when I try to group this and I factor out a 3x squared, there's nothing I can multiply 2x minus 5 by to get -63x plus 108. So this does not factor. Okay, so because it doesn't factor, then I am left, I'm forced to try synthetic division again. And again, like I said a moment ago, we're going to try the negative numbers here. So I am going to use these coefficients, remember, not the originals from the original problem, but now the simplified equations coefficients, and we're going to run through synthetic division again. We are going to try negatives, but keep in mind, this table no longer is helpful for us. It told us that there was at least one root between 0 and -1. But that doesn't mean that the other negative root, which we know there is another negative root, but that doesn't mean that the other negative root is also between 0 and -1. It could be any of these negative numbers from this list. So I'm left to just really try the numbers until I find some that work. Now, one thing that you might find helpful is taking a look at our coefficients and thinking about looking for possibility or similarities. And a couple people noticed in some of my classes that these numbers here are all divisible by 3. So they thought possibly maybe -1/3 would be a root again. So in some of my classes, we tried -1/3. Or some people said, well, let's try -3. Again, that was just by kind of looking at these numbers here and recognizing that they are all divisible by 3. So look for things like that, but some of this might be a little bit of guessing and checking. I will tell you, after a little bit of trying, we would realize that -3 actually does work. And now, when you're guessing and checking these different values, so 6 comes down, when I get about halfway, if I am really far away from the number that I know that I want, which by the way, if I want a 0 remainder, I want -108 here. So if I'm about halfway through synthetic division and I'm, let's say, in like a couple hundred, and then I'm multiplying by 3, so it's like 600. Well, if I know my ultimate goal is -108, and I'm here and I'm seeing that it's going to be way smaller or bigger than -108, I'm going to stop, okay? Because when you have such a long list and you're trying different ones, you're going to waste a whole lot of time if you just continue to go all the way to the end of synthetic division, even when it's obvious that it's not going to be working. So that's what I would suggest. But after some trial and error, we should realize that -3 is going to work. So 6 comes down times -3 is -18. Added to -15 is -33. Times -3 is +99. 99 minus 63 is 36. And 36 times -3 is -108. So we get a 0 remainder. And again, like when I was about right here, maybe -33, I'm thinking, is that real far away from -108? No, not really. It's relatively close, especially since we're multiplying. So that's why I kept going. So we just got that x equals -1/3 was a solution, and so is x equals -3. Now, I know that there are exactly 2 negative real roots because we already ruled out that there are 0. So there's 2, and we just found 2 negative real roots. So I'm not going to check any more negatives. If I have to continue trying different numbers from this list of synthetic division, I wouldn't try negatives. But I don't even have to try any more numbers from the list because it was degree 4. And then we did synthetic division once and then twice, which means it's 2 degrees less, which means these are the coefficients for a quadratic equation. We like that because we know how to solve quadratic equations. So 6x squared minus 33x plus 36 equals 0. And that is sometimes going to factor. This one does. But if it doesn't factor, remember, you can still solve quadratic equations. You know how. Sometimes you'll use a quadratic formula, or sometimes you'll complete the square, or sometimes even square root technique will work. But you can always solve a quadratic equation. So this one does factor. So we can pull a 3 out. So 2x squared. I don't know why my pen decided to stop working, but 2x squared minus 11x plus 12. And then factor that further. I don't know why this doesn't want to work. There we go. Yep, I think that's right. So x goodness. So x is equal to 3/2 or 4. Okay, so let me go back here and add those to my list. Now I have all of the roots. So it was degree 4, and I have 1, 2, 3, 4, 4 roots. So I have them all. And also, if I check, I did end up with 2 positives and 2 negative real roots. So I'm ready to graph. Now, each one of these roots or solutions occurred just one time each. So I didn't see 3/2 happen more than once. It just happened once. 4 just happened once. -1/3, I got it once. I didn't get it again. And same thing with -3. So each one of those are single roots. Single roots, remember, means that they're going to go through the graph at the x-axis and not bounce. So I'm ready for my graph. I'm going to plot the y-intercept and the roots and the end behavior, and I'll have my graph. So we have +4, we have +3/2, 1.5, we have -1/3 and -3, and we have up end behavior we said earlier, and we have 0, 36, so I'll just put that up high there. And I'm ready to go through and up to that y-intercept and through, and just labeling my intercept and my roots. So -3, 0, and -1/3, 0. And 3/2 to 0, and 4, 0. And there's my graph. Okay, and that's it. So the rest of class today was you were given time to work on finishing up, fixing up worksheet number 5. Anything that you didn't quite finish last night for homework, time was given in class to work on that. Questions if you had any. But really the key thing when you're working on these, and I mentioned this in class, is step 1, check the original equation and see if it's factorable. If it's factorable, and some of these will be, you can factor it right at the beginning, and then you don't even have to do Descartes or rational root theorem or a table. So that'll save you some time. So check to see if it's factorable at the beginning. And then if it's not, you're going to go through with Descartes, rational root, the table. You're going to use that information to help you know what to try with synthetic division the first time through. Remember, after the first time through, take your simplified equation and check again. See if it's factorable. If it is, you're going to save yourself time because then the rest of the problem can be done by factoring. If that's not factorable, then you go back to your list, you go back to your table, you go back to your information from Descartes, and that'll hopefully help you figure out what to try next with synthetic division the second time through. And then continue. And then you're going to continue going through synthetic division until either your simplified equation is factorable or it's quadratic. You've got it down to degree 2, in which case you can always solve. Even if it doesn't factor, even if it's not factorable, you can still solve it using quadratic formula or sometimes square roots technique or completing the square. So that's your ultimate goal, is to either get it to something that factors or something that's quadratic and you can solve using a different technique. Or hopefully, like I said, some of these are going to be factorable at the very beginning, and then you don't have to do any of this work. No Descartes, no rational root, no synthetic division. Just factor it, and you know your roots, and then graph from your roots. And the last thing I want to mention that I also mentioned in class is just be aware that when you're doing this table is not you finding the roots. Like let's say one of these gave me 0 for y. That tells me, let's say like 1 gave me 0. That tells me that 1 is a root, but that doesn't keep me from having to do synthetic division. All that does, if I get 1, 0, is tells me that I should try 1 in synthetic division. Okay, so what I'm saying is this table here does not count as me getting a root. I get the root when I use synthetic division and I get a 0 remainder, or when I factor it and I get x equals 1. So you don't count that table. That table really is just a guide. It's a helpful hint as to what to try. So if I get x equals 1 again, let's say, here with synthetic division and I get a 0 remainder, If I later at some point either try synthetic division again with x equals 1, or if I factor and then solve later and get x equals 1 again, then I'm going to count the x equals 1 here that I got and the first time that I got it with synthetic division, and that would be meaning that x equals 1 twice, which means x equals 1 is a double root, in which case when I graph, I would make the graph bounce at x equals 1. So just keep that in mind, that sometimes you'll get an answer more than one time, which means it's a double or a triple root, and then you'll have to graph accordingly. But when you're checking that to see if it occurs more than once, occurring here in the table doesn't count as being a root. So I wouldn't like count it here, 1, 0. I wouldn't say that's the first time it occurs and then count it again with synthetic division. That's still just occurring only once. So it's only down here that you count and say, oh, if I see it again, if I see it once, if I see it again, that's a double root or a triple root. Okay, so you're going to work on finishing up worksheet 5, and then homework for tonight is worksheet 6, and anything that you still have to finish up on worksheet 5 is also due tomorrow. So please come in tomorrow with both worksheets 5 and 6 completed. And next week you do have a test on Wednesday.